And welcome to Chapter 2. We're going to be covering input and output along with some processing in this chapter. This chapter, you're going to start learning about how to design a program, what you need to do to make sure that you do it well and do it right, and how to use Python to do that. Let's get started. So when we design a program, it's really important for you to understand what your program is supposed to do. It sounds silly and obvious, but you would be amazed how many people actually just sit down and start writing the code without taking the time to design it, figuring out what it is they really want to do. These first couple of projects that you're going to do, you can do that. You could probably sit down and just start writing it and you'll be fine. But as your code gets more and more complicated, it's going to be more important that you do take the time to design your program. The way we just do this is we can sit down and we design our algorithm. An algorithm is simply a description of how to do whatever the task is you're trying to do. So if I wanted to make a peanut butter and jelly sandwich, I would want to take the bread and the peanut butter and the jelly. Okay, I need to think about what happens if there is no peanut butter. Which kind of jelly do I want? Which kind of bread? Do I get the bread out of the bread box? Do I keep it in the fridge? How am I going to handle that? So when you stop to think about how to do a program, you'll start thinking about all of these little cases and what you need to do in your program to handle those cases. So first step of designing your program is to write or design your algorithm. Come up with a description of what it is you want to do. And you're going to write this down in regular words in English, just saying, I'm going to do this, and then I'm going to do that. Oh, and then I think I'm going to do this here, and this is how I'm going to do that. It takes time, and I want you to understand this class is going to go by very fast, and there's a lot of programming that you're going to do. If you don't take the time to actually analyze your algorithms, you're going to find yourself redoing them, doing them 2 or 3 times. It's kind of like cooking. If you cook wrong, if you do the wrong measurements and you add 4 eggs instead of 2 eggs, you've ruined everything. You have to start back over from scratch. So a couple of different design methods that we're going to talk about doing. The first is iterative design. And iterative design, to iterate, means to go over and over multiple times. X number of times you iterate. Iterative design refers to designing your program, writing your program, implementing the whole thing, finding out if it works. If it doesn't work, go back to the beginning and redesign it, then rewrite it, then retest it, then find out if it works. So there's a lot of repetition in coding, and you have to kind of get used to that. You can't expect yourself to be perfect right out and to do all of your code perfectly the first time. After you've figured out your algorithm and you've written it all down and you've designed it and you think you've got most of the cases covered, you're going to start writing your code. This is where Python's going to come in. If you want to continue in computer science and move on to other languages, learning how to program at the beginning is going to help you a lot. So now you've got your algorithm, you're going to sit down and you're going to write your code. Code is broken into what I call syntax and semantics. Syntax is the actual errors in the logic of the code. So did you write it correctly? They're the grammar rules. They're the things that say you have to put a verb after a noun and you have to conjugate your verbs correctly. These are just grammar rules in the language. So does your language use semicolons? Yes or no? Does your language use curly braces or non-curly braces? What is the actual syntax of an if statement? Do we use the word else in there? Do we use the word then? Couple of things. These are just syntax rules for the language. When you sit down to write a program, you don't have to know what language you're writing it in because you're just kind of writing out your algorithm. But once you start to write the code, you're going to have to follow the logic and the syntax rules of that language. So the first thing we do is we write our code and we say, is there any syntax errors? When you run your code in the interpreter, you're going to find out quickly whether or not you have syntax errors. We're going to go over those in a minute when we start actually looking at some code. If you have syntax errors, go fix them. Go fix your syntax errors in your code and check again. Do you still have syntax errors? Go fix it again. Sometimes you do this 5, 6, 8, 20 times till you can get rid of all your syntax errors. Once you have all of your syntax errors cleaned, you have no more syntax errors, now we're going to run the code. You run it and then find out whether it does exactly what it's supposed to do. This is where we get into semantics or logic. Do you have any logic errors? Did you try to withdraw money from your bank account when your bank account balance was zero? Did you do something wrong, try to enroll a student in a class when the student actually had no student ID? Were there some logic errors, something you forgot to do in your code? When you had meant to make that peanut butter and jelly sandwich, was there no peanut butter? Was there no jelly? Did you pick jelly? Did you pick your choice? These are more of logic errors. Your code was all written fine in Python, but the algorithm might have been a little off. Maybe you didn't think about something. If I'm going to go walk outside, did I forget to open the front door? Find those logic errors. If you have them, if there are any, now you go all the way back to the beginning and you say, I'm going to redesign my program because I broke something. I didn't design it correctly. I have to fix that. Then you fix the code and you check for syntax errors because you just changed the code. Every change of a piece of code could result in a new syntax error. Always test your code. Do not turn code into me that has not been tested. And I know whether you tested it or not, because if you turn it in and said it works and I run it and it immediately has a syntax error, there's no way you could have tested it. Every single line of code you change, anytime you touch the code, you have to retest it because you could break it again. So, did you have any logic errors? If you get to the point there are no logic errors, cool, you're done. That's the end of the program. Everything works and you're fine. Make sure when you're programming that you follow all of these steps. Write your algorithm, write your code, check for syntax errors, test your program, check for logic errors. The fun thing about logic errors is your code could run 50-80% of the time, but 20% of the time it'll break. I'm testing for those cases, that 20% of the time where it breaks, and I'm going to know. So that's something you want to check for. So when we did that peanut butter and jelly sandwich, did you check to see if there was peanut butter left in the jar or was it empty? This is just a question you need to ask. And how did you handle it if it was empty? So you're going to check for syntax errors, check for semantic, logic errors, and then turn in your code. Just because it runs doesn't mean it's right. So in the previous slide, I talked about your algorithm. Your algorithm is your description of your project. You can design your algorithm in one of two ways. You can actually design it in a lot of different ways, but the two ways I'm going to explain. You can write it in pseudocode. Pseudocode is fake code. It's not real code. It's not formal. There is no formalization of the code and there is no syntax rules. So that question about semicolons and curly braces doesn't apply to pseudocode. Pseudocode is not language specific. It can be translated into any high level language. So you can turn it into Java, you can turn it into Python, you can turn it into C#, you can turn it into F#, you can turn it into COBOL, maybe. But your pseudocode is just a series of commands or suggestions on how you're going to write your code. You're writing commands and you're creating modules or models of how you're going to do this. So if we're looking at the code here, we're going to input the number of hours worked, we're going to input the hourly rate, we're going to calculate our gross pay, and then we're going to display it. That's pretty simple pseudocode. There's no code in there. None of this is written in Python at this point, but it's just kind of a description of what you're going to do. The other way that you can build your algorithm is with flowcharts. And some people really like the visual aspect of a flowchart. When you use your flowchart, there's different symbols for different aspects of the code. So our start and end, we usually start with an oval. So we say we're going to start at the beginning, and then how are we going to workflow through our project? Well, first we have to get our inputs. So those are the hours worked and the hourly pay. Those are going to be in a parallelogram. So the ones with slanted sides of a rectangle, not straight up and down sides. And then our commands are going to be in rectangles. So that's the calculate the gross pay. That's just going to be a statement that you're going to write to calculate it. And then we're going to display our gross pay, which is an output. And then again, a end. If we're going to have a decision, which we're going to do if and else in a couple of chapters, those would be in diamonds. So rectangles on their sides, squares on their side, diamonds. We're going to use a couple of different applications to design workflows and flowcharts. So I'm going to show you some of those things in the future. but that may be something you want to do on a computer, and you may just want to scribble them on a piece of paper. It's fine. You can scribble stuff on paper when you're writing code. You don't have to type everything into a program. Okay, so these are the basics of how to build your program. Most of the programs that you're going to write are going to follow the basic workflow of take some input, do something with it, and put something out. Input, process, output. So in the case that we've been talking about of figuring out how much money we're going to make, our input is our hours worked and our hourly pay. Our processing is the actual calculation where we multiply those two together. And our output is what we're going to print back out on the screen, which is that total gross pay. So this basic concept of input, process, output, you're going to do a whole lot of times. Okay, so you're going to get kind of used to that idea. Take some input from a user, do something with it, and then print something out to the user that was somehow the processed calculation of what you were doing. The first thing I'm going to teach you in Python is how to display out to the terminal. So we're going to walk through printing out to the terminal by writing our hello world. Couple of things on this screen. First off, functions. Just like in your math class, functions can have a parameter. So if we had f of x as a function in our math class, same concept. It's a function with a parameter of x. We can have a different parameter with different types of functions. So you can have a string, or you could have a number, or you could have even an object, and we'll get into that with classes. So functions are designed so that they take some sort of input parameters and they do something. Functions can also have a return value. They can return a value. So I can have a function like add two numbers, and it takes two numbers as its input, adds them together, and then outputs the sum of those two numbers. So our functions can take an input, do something in there. They don't have to take an input. You can have a function without an input. You just keep open and close parentheses with no parameter inside of it. You can also have a function that doesn't return anything. We call this returning void, or returning nothing, returning null. In this case, our function doesn't, it does some calculations, but it doesn't actually return a value. We'll see how that's actually possible with global values and how to store things in the future. So the first function we're going to play with is our print function. Printing something just prints it out to the terminal. So when you're writing your code, it's going to print down at the bottom. So we're going to print hello world. Now I have the code down here. The print function takes a string, which is any subset of text with double quotes, either double or single quotes. And we call that a string. So a string literal is the any text that you could put in there. Hello, goodbye, goober. Those are all string literals. You could put them inside quotes, and those can now be passed into our print function to allow us to print that out to the terminal. Something a little extra on here, and you'll notice that it's color coded. That's why I like to use Visual Studio. Color coding is really convenient for programmers because it helps you to recognize what things are just by glancing at them. In the code that I have below, I'm using a hashtag or a pound symbol if you're old like me, to separate out things that I've written that are not code. These are called comments. So comments are things that you want to write in your code to give notes to the other people that are seeing your code. By the way, that person might be you. I have written code that I wish I had commented more. So if I had put some comments in, what on earth was this function supposed to do? I don't remember. It was a year ago. Golly, I wish I'd put some comments so that I would do that. In this course, I will require a header comment on every single file you submit. So in this case, I've given you an example of a header comment. It's going to say who wrote it, your name, the date that you wrote it, the file name itself, and then a description of that file. So what is this project? What is it for? What chapter? What exercise number? Things like that. Those are going to go into your header. When you put codes in your header, Python will not read them. They won't even look at them. They'll go, oh, this is a header. I don't care. This is a comment. We're skipping past it and we're going right down to the code. You'll also notice in this piece of code that the hello world is in red because Visual Studio Code will color code any string literal will show up as red. By the way, you can change your theme colors. So yours may not be red, yours may not be green if you've changed your theme colors in Visual Studio Code. All right, just a couple of little things to show you. I'm in Visual Studio Code. By the way, if you are not in the theme of dark, I like the dark theme, but you can change your color theme. So I like the dark here. This is probably the one bright that you're looking at. But, you know, everybody has their own difference. So I'm going to go back to my dark because that's just really bright. Okay, so basics of being able to use the print statement and some basics of Visual Studio. Your environment should look like this. We should have already covered this. So you should be comfortable with this. Remember, if you're going to put comments, hashtag, and I can say, this is my test code. Just to have some sort of commentary of what's going on. One of the things I like to do when I write my code is to comment my pseudocode throughout the whole thing. So I could say, printing my information, and then I'll start doing my code. Print, we'll do my name. And you can see as we start typing that Visual Studio Code will fill in some things for you. I didn't have to type the closing quote or the closing parenthesis. It figured those out as we went along. And you can do multiple print statements. My town, Montana, 9401. I must have hit the F button in my hand. Okay, so I have a couple of things here. If I want to print this and actually have it run so I can test it, see if it works, couple of ways you can do that. First is you can come over here to the debugger, this little thing with a little bug, and he's got the little run symbol here. Got a little confusing on the older versions because it was just a bug and no one could find the run statement and everyone was kind of confused. And in this case, the little bug's right here. So I can open that up. This opens and closes as you open it. So my Explorer opens and closes. Come here and click the little run button. And it should print down here in my terminal, which is where we are going. See, Cheryl Simpson, 123 Main Street, my town. Again, this stuff, yes, it shows up. Yes, it's kind of annoying. If I wanted to change it to 456 Main Street, whoops, I could do 456 Main Street and then hit run, and it should print now 456 Main Street. So you can see how that goes. If for some reason your code is not working, if you're trying to write it and you can't get it to work, please go find me on Teams. Go onto Teams, go to the chat, say, Cheryl, I have a question. I can't get my Python to run correctly. And we can share screens, or we can use what we call live share. Live share, yeah, we're going to cover live share in a different video. Okay, so that's how you would print. And as you can see, I can go in and change these things. A couple of the homework assignments from this chapter are going to be similar to this. Again, you're going to want to make sure you do your hashtag with your comments and your print statements, and you can see how they color code a little differently. Okay? Okay, so after that example of how to use the Python and get your print world or hello world working and getting some printing, let's talk about variables. Yes, variables are just like they were in high school, where x equals 5. Variable is just a name that we use to represent some value that's stored in memory. Now this memory is going to be stored on your RAM, so it is not going on your hard drive. You are not storing it to a file yet. We'll deal with that in a couple of chapters. But for right now, it's just being stored in your RAM, and it's just hanging out there as long as your program is running. As soon as your program ends, all of that memory gets cleared and goes away. And variable is set with what we call an assignment. The assignment is just the equal sign, just like it was in high school math. So x equals 4 is going to set the variable x equal to the value of 4. In this case, 4 is the integer 4. You cannot assign to a literal. Literals are either numbers or strings or booleans, but they are like 4, -1, the quote hello quote. You cannot say x is equal or 4 is equal to x. You say x is equal to 4, x can be your variable, but 4 is not a variable. 4 is literal. So you can think of it as a variable is a letter that represents, a letter or letters, a word, that represents a value in some sense. You wouldn't say 4 can now be equal to 23. That wouldn't make any sense. So your literals cannot be assigned to directly, which is fine. But you can assign a literal to a variable. So we're going to be using a lot of variables. Couple of special naming rules in Python. First off, no keywords. If you look in your book, you'll find a list of keywords. There's a lot, well, there's a lot of them, but you'll recognize them. They're words that are really, you'll see as we move along in Python, very specific keywords. The word if, the word class, the word import. These are words that are useful in the language, and we can't name our variable that name. So you can't use the keywords. No spaces, really important. A variable has to be a single contained group of letters. So it can be a series of letters that are connected together that don't have any meaning, or it can be a series of words that are in some way combined. When we use multiple words, if I wanted to say my name, my house, my dog, I could put my and an underscore. So I could use underscores. Underscores are allowed. Numbers or letters are allowed, but the first character of your variable has to be a letter or an underscore, no numbers. You cannot have the number as the first character of your variable name. It can be any other character in your variable name, but not the first. And again, no spaces. So if you want to put a space in for that visual, you can use an underscore. One of the things that I like to do is do something called camel case, which is where our first letter is a lowercase letter of the word. So first word. If I have 3 words, I will do the first letter is lowercase of the first word. The second word will be all bunched together, but the second word will be capitalized. And then everything else is lowercase. And then the third word is capitalized, and then everything else is lowercase. And this is called camel case. It goes up and down and up and down. But it's a visual way of being able to recognize multiple words in a variable name. Also recognize with your variables, the capital and lower letters are 2 completely different letters. Remember that ASCII list of letters. Capital A is 65, lowercase a is 97. They're 2 totally different letters. So when you reference your variables in your code, you have to spell them exactly the same way you spelt them when you instantiated them, when you created them. So when we assigned them the first time, you can create a variable and assign to it multiple times. It's called mutable. It's allowed to be changed. Let's keep going. We looked at the basics of a print statement that just took a single variable. You can actually have multiple arguments in your print statement. All you have to do is separate them by a comma. So you can have multiple arguments or multiple parameters in your print statement. In this case, I have printed both my name and my phone number next to each other. When you do a print statement, there are things called the separator, and there is a thing called the end character. The separator is what do you want to put between multiple successive parameters. In this case, I put name and then phone number. The default separator is a space. So it's going to print Cheryl Simpson with a space and then the phone number. You can change that. We'll talk about how to change that when we get into more printing options, but that is something you can do. Also, the default end character is a new line character. It defaults to always put a new line after each print statement. So you may have noticed when we did our printing before that we did print name, print address, print city, state, zip, and it put them all on separate lines. That's because the default end character of a print statement is always a new line. Okay, when we're working in code, it's very important to recognize your data type. Okay, if you have coded before, you probably recognize the difference between numbers and strings, objects, characters, booleans. But if you've never worked with code before, these might be new words for you. So I want to kind of explain them a little bit. First off, numbers. We have 2 different types of data types for numbers that we use in programming. The first is an integer. So if you remember again back to high school math, an integer is a whole number, positive or negative, that you can use. There's no decimal place to it, no fraction, no decimal place that goes with it. It's just a whole number. Those are integers. The other option is what we call a floating point number, a float or a decimal. Sometimes we call it a double. There's a couple of different ways that we reference a floating point number, or one that has a decimal place and some list of numbers after it. So if you had 2.36, that would be a floating point number. Strings can be written either with a single or a double quote. This is one of those things where I said programming is like art. You're going to decide how you like strings. Do you like them with a single quote or a double quote? And you're going to consistently use that. I may have a double quote. You may have a single quote. Either way is fine. They both work. The one thing about a single quote and a double quote, if you decide to have an apostrophe in your text, so if I wanted to use a contraction of some type, can't, don't, haven't, something like that with an apostrophe. If I use a single quote to surround my string literal, that apostrophe is going to confuse the crap out of your compiler. You're going to have to use double quotes, or you're going to have to escape the character. We'll talk about escaping characters when we get further into strings. If you want to find the data type of your variable, you can type the word type with the variable inside parentheses. That's the parameter of the type function. And the type function will return what class that variable is. A variable is mutable. It can be changed. So as you can see over on the left-hand side, x is equal to 5. And then we checked its type, and its type was an integer. Cool. Then we changed x to be hello, and its type was a string. And then we changed it to 1.0, and its type was a float. So you can see that that type of that variable can change as you change the values of the variable. They don't have to stay typed. Python is not what we call strongly typed. There are languages that are. Once you define it in integer, you cannot change it to something else. It will always be an integer. But in Python, we can do that. We can change things around. So remember what I said about literals. Literals are the actual number or the string, whereas the named variable or the name is the variable name that holds a literal value. Variables can be reassigned at any time to any value. You can see over on the right-hand side that our number 99 is our literal, x is our named value. Okay? All right, now that I think we've covered data types, we're going to start talking about inputs or getting information from the user. The user usually has information that you want to do something with. You want to ask him questions. You want to ask the user what to do about something, and he's going to turn around and give you some pieces of information. To do that, we are going to use a function called input. Input will prompt the user in the terminal to ask a question. And in this case, we have to give it a prompt. The input function will take a parameter that we call a prompt of whatever you want to type in to have the user ask the question. In this case, I could say, please enter a number, or please enter your name. And these would be different things that you would put in the input prompt to make sure that the user knows what you're asking for. If you just did input with no prompt, the user won't know what you're asking for, so he won't ever put in the right, he might put in the right information, but he may not. So we want to make sure we prompt our user well. When you write your prompts, again, this is one of those personal things of how you like to write your prompts. I like to put the prompt, and then I like to put two little tiny arrows, which are greater than symbols, just so that they can see where they're going to enter the word 5 or the name Cheryl or something like that. You might put up a colon. That may be your thing for a prompt. But you're going to come up with your way of doing that. In the prompt, you can either do a literal string or you can do a variable. So I can have a variable called prompt, and that's what the string is going to be, and then I can pass that variable into my function. That's totally allowed. If you want to read in a number, sometimes you want to read in an integer and sometimes you want to read in a float. If you read in, using the input, the expression value is going to be a string. It always comes out as a string. That's what the user entered in the terminal. If the user entered a string and you want that to be an integer because you want to do some math on it, you need to do what we call casting. You need to cast it as an integer. So you need to change the value from a string into an integer. So if you look at the code over on the right-hand side, you can see that I put the word int as a function name, int, and I put in parentheses, and then inside of that I have the input. So I am taking the value from the input and I'm passing it into the method int to turn that value into an integer. This is called chaining methods, and we're going to do this a little bit more when we get into functions and methods. But we have essentially done two functions at the same time. We've done one function, we've gotten the result value of that function, and we've passed it as a parameter to our second function. In this case, we've done our input, gotten the value from the input, and taken that and passed it as a parameter into our integer cast function. You can cast into an integer, you can cast into a float, you can cast into a string. Input is already a string. We don't need to cast input into a string. But you can cast a value that's an integer or a float into a string by using the same methodology of saying string, str, and then parentheses and passing in a number. Okay, so these are casting of values into numbers so that you can take your input value and turn it into a number so you can do some math on that number. A couple of different arithmetic calculations. So we're going to do some math. Computers are great because they do math so much faster than we can ever possibly do math. The basic math functions, addition, subtraction, multiplication, and division, all exist inside of Python. So plus and minus, the star, which is shift 8. There we go. The star, unless you have a 10 key. If you have a 10 key, you know where the star is on your 10 key, but the star is multiplication. It's not an X. X is not a star. X is a variable. So star means multiplication. And the slash, this is the backslash that's underneath the question mark, usually next to your shift key. And that's going to be your division. All right, there is a secondary method. There's actually a few others. Integer division. If I want my division to always return an integer, I can use 2 slashes instead of 1, and that will tell it that I want integer division. If my value is positive, it will be truncated, which means it will be cut off. If I got 3.9, the result will be 3. It will truncate off that 0.9. It will not round it. If it is negative, it will round it away from 0. So if I had negative 2.1, it will round it away from 0 and turn it into negative 3. Okay, that's integer division. It will take a decimal result of a division and turn it into an integer by truncating off the end. There is also a method called modulus, which if you haven't done any programming might seem a little weird to you. When you do division, if you remember long division, in long division, you end up sometimes with a remainder. If I take 5 and divide it by 2, I'm going to end up with 2.5, right? I'm going to have that remainder. I'm going to have 1 left. So when I do my long division, my 2, 5, and I'm going to get a 2. I'm going to carry the 1. I'm going to end up with 1 left over, 1/2, right? That 1 is a remainder. So whatever your remainder is from a division, this may seem like a weird method to have, but you'll find that it is extremely useful in working with math problems. There's a lot of times that you're going to say, I want to know what the whole number of this division is, and I want to know what the remainder of this division is. That remainder is the symbol modulus, which is used by a percent sign. So we can do, as you can see over in the examples, x modulus y. If in this case x is 5 and y is 10, x modulus y is going to return 5, because you have 5 as the remainder of x modulus y. Y modulus x is going to give you a remainder of 0, because 10 divided by 5 can go in evenly, and there is no remainder of that. That's modulus. Exponents, powers, is 2 stars. So we use 2 stars right next to each other instead of just 1, and that will get you powers. So we can get y to the power of x for exponents. Your precedence is similar to what we did in high school. Again, that PEDMUS, if you remember the please excuse my dear Aunt Sally, something like that. PEDMUS always starts with parentheses. So if you put parentheses, they will always get done first. Everything inside the parentheses gets done first. Use parentheses to ensure that you get the right precedence. It's really important that your precedence goes right. Next is exponents. Next is multiplication, division, and modulus, because modulus is essentially a division problem. The 3 of those in order, left to right. And then addition and subtraction after that. So your order of precedence is very similar to your high school math order of precedence. and with the exception of that, we've added this modulus concept. Okay, basic mathematical calculations. This is where you're going to pause the video and you're going to go write some code. Okay, you're going to open up your idle, or you're going to open up your VS Code, and you're going to write the code to create this function. I want to see if you can do it. I want to see if you can. I want you to see that you can do it. This is a math formula. This is present value, future value, interest rate, number of years. We're calculating how much something is going to be worth in the future with a certain calculation of interest rates. This is cool. We like being able to do math by letting the computer do it for us, because computers are faster than we are. So you're going to have to think of what are the math operations that are going on here. You're going to need to ask your user, what is the future value? What is the interest rate? And what is the number of years? So those three variables that are over on the right-hand side of your equation, the F, the R, and the N, are used to calculate P, which is what we're trying to find, the present value. Okay, so I'm going to go ahead and stop talking and let you pause the video. I want you to go write this code. Get to the point that you can see the value and you can see the results. When you put in $10,000 at 5% for 10 years, you need to put $6,139.13 into your computer now, or into your account now. Okay, go play with this and then come back when you're done. All right, so hopefully you had some fun doing that project. You got through it okay, and it got all the answers right, so that was good. We're going to talk about a little bit more about the print function, and we talked about it already, passing two parameters through. Now we're going to talk about that separator and end character, things that we can do with it. So the default behavior for the print function is just a single variable, and it adds a new line at the end. The default print with multiple parameters separates them by a space. So if you don't do anything else different, those two things should work fine. You can change the behavior of both the separator and the end character by changing those. You would type in SEP for separator equals and then change it, or END for end character. So if you want to put a space at the end, you can just put a space in for your end character. If you want to have nothing at the end, you can put in two double quotes with nothing between them. Same for the separator. You can do that with either a comma, which is always fun if you want to put a comma between options, a comma and a space. You can put a /n or a /t. These are special escape characters, and they're pretty common across other languages, so learning them isn't just a Pythonism. /n, and this, by the way, is the other slash, not the one with the question mark, the one that's usually above your enter key. So this is a backslash, and you put the slash and an N, and N means next line, new line. You can also do a T, which is a tab character. So if you want to have things lined up nicely with a tab character, tabs are great. You can put in a single quotation mark or a single quote mark if you wanted to print that, to print quote marks. You can just put a slash to escape the quote. Same with a double quote. And if you actually wanted a backslash printed, you could put two backslashes. So changing the end behavior, changing the separator, some of the escape characters. You can also format your strings. This is something that you would want to do with numbers. So if you want to pass a number through and put it with two decimal places, you'll notice the more you write code that a float or a floating point number might be an infinite, repeating decimal. It might be a decimal that goes on for a long time. And you want it to just print with two characters or two decimal points because that's what we do consistently. If you want to do that, you can use the format function. It takes a number, either a float, actually it takes a float, and in this case we're going to do a format string. In this case it's a quote and a period and a 2 with an F. Okay, what does each of these mean? You can also do it with a comma. Okay, if you put a comma in that order, so comma, period, 2F, the comma says I want to put my commas between my different periods of numbers. So if I had thousands, I would want 2000 comma 126 point and then my decimals. The 0.2 says how many decimal places. So if I wanted 3 decimal places, I could put 0.3. If I wanted 1 decimal place, I could put 0.1. And then the F tells you that the parameter that you're passing through is a float. It's a floating point number. It's going to look for a floating point number, and it's going to try to format it in this format. You're going to notice this is really convenient when you're trying to make your numbers look pretty. The other thing we can do with a print is we can concatenate together or chain together two items with a plus sign. So two strings with a plus sign between them will concatenate two strings together. They just take them and push them right together. We can do this if we have multiple strings in multiple variables and we want to concatenate those three variables together. Concatenation is really common in string manipulation. So really a useful thing to learn. Sometimes when you're using variables, you want to have a constant or a variable that you do not want to change. The naming convention that we use for those variables is all capitals. If I put in all capital letters, that usually tells people this is a named constant and it's not going to change. We're not yelling. It's okay. I know all capitals is really weird. In this case, we also don't do a lot of camel case because we wouldn't go up and down in capital and lowercase. So we would use that underscore to separate words. So in this case, we have interest underscore rate to refer to our interest rate. In code, beginning programmers will often use what we call magic numbers. If they want to do printing out a number, they'll just have a number randomly in there. So we're going to print 3. Cool. What did 3 stand for? What was it for? What did it mean? Did it actually refer to something? If I multiplied my balance by 0.069, why is it 0.069? What does that mean? And you're not really telling the user anything about that number. You're just using a magic number in the middle of the code. It is much better to create a named constant called interest rate, make that 0.069, and then passing the interest rate in as a parameter or into your mathematic calculations at that point. Because when the user looks at it, they know what that means. That 0.69, it's not just a magic number in the middle of your code. It actually means something. And it's really, really a useful thing. I'd like you to avoid magic numbers in the middle of your code. And I'll call you on it when I'm grading your code. I'm going to say, hey, you had a magic number on line 34. Try to avoid your magic numbers. Okay, so those are just random numbers in your code where they could have been a named constant that you could have set to let the users and the people that are looking at your code understand better what those numbers mean. There is a section at the end called turtle graphics, and turtle graphics are kind of the fun stuff. You're playing around with a turtle, which is what we call this little triangle that we play with, and you're drawing. So we're going to do some drawing. I do want you to play around a little bit with the turtle, and I am going to assign some problems that have to do with the turtle in each chapter, just because I think it's kind of adds a new different way of looking at it. A lot of our programs are going to be very linear, very procedural. You're just going to go down and write code, and it's going to get kind of boring. So I'm going to give you the opportunity to start playing with a little bit of turtle graphics to be able to move stuff around. The turtle, which is the little triangle that moves around, is going to be able to move through your code. You're going to be able to move him forward, backwards. You're going to be able to turn him specific degrees. You're going to be able to change his color. Is he blue? Is he red? And you're going to be able to do things like that with him. So I would like you to play around a little bit with the part of the chapter in the book about turtle graphics and be able to understand how to use it, how to import it, how to write the code, and how to make it work. Okay, so on to your homework assignments. For chapter 2, you're going to do exercises 1 through 4. You can use a single file to complete them all and make sure you comment the top of the file along with each separate exercise. So you're going to be writing about 4 or 5 lines of code per exercise. So I want you to do a comment before you start those 4 or 5 lines of code that says, this is exercise 1. I'm going to be doing blank. And then write that code. And then underneath that, you can put a little comment that says, this is exercise 2, and I'm doing blank, and then write the code. So you don't have to submit 4 pages, 4 different files of code. You can just write one code that has all 4 of them, but just make sure that you comment the top, explain what you're doing, and then submit those. After you're finished with 1 through 4, we're going to move on. The second part is more mathematical, and I kind of separated it into 2 parts. Just because the first is really just learning input and output and printing, whereas the second one is a little bit more math. Again, you can do one file for all 3 exercises as long as you comment the top of the code that says this is exercise 7, this is exercise 8, this is exercise 9, and each of them are on one file with comments between them. Make sure that you test your code and that it looks nice, so it doesn't look sloppy and it doesn't look difficult to read. Okay, so make sure you create any variables for numbers that before you're printing them out, because I don't want those magic numbers, so be careful with that. And then we'll talk about adding mathematical operations inside your print statement later. So if you're going to be calculating or adding 2 or 3 numbers, add them together, save them as a variable, and then print out that variable. Don't try to do all of the math inside of your print statement. The last exercise for chapter 2 I want you to do is number 15. You do not have to make all of these images, but I want you to do at least 3 of them. So go to the end of the chapter and look at problem number 15, and there are 6 little images there that they've made in Turtle Graphics. I want you to make at least 3 of them. If you want to make all 6, that's awesome. That'll impress me. But you only have to do 3. Pick the 3 that you find the most interesting, and go ahead and write those in your Turtle Graphics, and then add those into your homework assignment that you're going to be turning in. So you'll turn in 2 files, or 3 files for chapter 2. So 1 through 4, 7 through 9, and then number 15. Have a great week. Please contact me if you have any questions at all, and I will talk to you soon.